Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students! Today we are going to continue with class 9 science chapter number 3 current electricity. Topics that I am going to cover during this session are electric current, Ohm's law and resistance, electric circuit and its components, and finally we will see few solved examples on Ohm's law and resistivity. Let us start with electric current. Electric current. It can be defined as the flow of electrons through a conductor. Quantitatively, current can be defined as the charge passing through a conductor in unit time. If the charge Q is flowing through the cross section of the conductor in time t, then we get the formula I is equal to Q upon T. That is, current is equal to charge upon time taken, Q upon T. So we get Q equal to IT. It can be represented with the help of this triangle. Q is equal to IT. The SI units of current is ampere, that of charge is coulombs, and time is seconds. Let us solve an example. A current of 0.4 ampere flows through a conductor for 5 minutes. How much charge would have passed through the conductor? So the given quantities are current, that is 0.4 amperes, and it is flowing through the conductor for 5 minutes. So time taken is 5 minutes. Let us convert minutes into seconds. So it will be 5 into 60 seconds, because 1 minute is equal to 60 seconds. So 5 minutes is equal to 5 into 60, that is 300 seconds. We have the quantities I and T with us. So we want to find out now the charge that is flowing through the conductor, that is Q. And we also have the formula, that is Q is equal to IT. So we will place the values of current as well as time, and we will get the charge passing through the conductor, that is equal to 120 coulombs. A German scientist named George Simon Ohm gave the relationship between the current flowing through a wire and the potential difference across the two ends of the wire. According to this law, if the physical state of the conductor remains constant, that means its length, area of cross section, temperature, and the material that it is made up of, if all these things remains constant, then the current flowing through the conductor is directly proportional to the potential difference between its two ends. So in formula, it can be stated as V is equals to IR, where V is the potential difference, I is the electric current, and R is the resistance. Measured in ohms, the unit of resistance is ohm, and it is indicated by this symbol. So this formula can also be written in the form of triangle, that is V is equals to IR. Let us see how this formula was derived. Now, as per the Ohm's law, the current flowing through the conductor is directly proportional to the voltage, right? So I is directly proportional to V. To remove this proportionality symbol, constant K is added to the equation. So I is equals to kV. If we take K on the left hand side, it will go in the denominator. That is, I upon K is equal to V. Now 1 upon K is another constant, that is the resistance of conductor. So we get the formula I into R is equals to V. That is nothing but V is equals to IR, or resistance is equal to voltage upon current. So this is known as Ohm's law. Resistance. This picture shows how a resistance look like in an electric circuit. In order to understand resistance, consider this picture. As you can see over here, there are large number of electrons which are moving freely in the conductor. Now, they are constantly in random motion. When the potential difference is applied between the two ends of the conductor, these electrons starts moving from the end at the lower potential to the end at the higher potential. This directional motion of the electron causes the flow of current. Now, moving electrons strike the atoms and the ions which lie inside their path. So, such collision causes hindrance to the flow of electrons and it opposes the current. This hindrance is called the resistance of the conductor. Over here, picture shows an electric circuit. This is ammeter, this is voltmeter, these are the connecting wires, and over here this is a cell which generates the potential difference because of which current is flowing in the circuit. Over here you can see resistance. It is indicated with this zigzag lines. So this is the symbol of resistance in an electric circuit. Now let us understand what is resistivity. At a given temperature, the resistance of the conductor depends on its length as well as the cross-sectional area. We can say that resistance is directly proportional to the length because more is the length, more will be the resistance. And resistance is inversely proportional to the area of cross-section because if the area of cross-section is more, resistance will be less. And if the area is less, resistance will be more. So R is directly proportional to L and it is inversely proportional to A. So if we combine both these equations, we get R is directly proportional to L upon A. To remove this proportionality symbol, we will put a constant, that is R is equals to rho into L upon A. Rho is the constant of proportionality and is called the resistivity of the material. So we get the formula as rho is equals to R into A upon L and its SI unit is ohm meter. Conductors like metals and alloy, they have low resistivity, like 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. Whereas insulators like rubber, glass, etc., they have high resistivity ranging from 10 raised to 12 ohm meter to 10 raised to 17 ohm meter. Now this picture shows the symbols that are used in the circuit. This symbol is for a cell, which is the source of current electricity. This symbol shows a battery. Battery is nothing but it is the combination of two or more cells. Over here you can see there are 3 cells joined together to form a battery. Then this symbol is for light bulb. It converts the electrical energy into the thermal energy. This is the symbol for motor, which converts the electrical energy into mechanical energy. This is the symbol for a switch. You can open it to stop the current and you can close it to allow the current to flow. These are the symbols of ammeter and voltmeter. Ammeter is used for measuring the current and voltmeter is used to measure the voltage. This is the symbol of resistor, a device that slows the flow of electrons. And finally, this symbol is ground connection. It connects the circuit to the earth. Conductors and insulators. Any material that allows electric current to pass through it, they are called conductors. For example, copper, aluminium, steel. Mostly all the metals are the conductors of electric current. Insulator. Any material that does not allow electric current to pass through it, they are called insulators. For example, plastic, rubber, glass, cloth, wood, etc. Now, what exactly are insulators? Why they are not allowing the electric current to flow through them? Atoms of insulating material, they hold on tightly to their outer electrons, like good parents watching all their children. Whereas the copper, which is a conducting material, it tends to be a poor parent of their outer or the valence electrons, as they are just out wandering the neighborhood. So this is the reason that why insulating material don't allow the electricity to pass through it, because they hold on their electrons very tightly, whereas opposite is the case in the conductors. Their electrons are wandering freely. Let us solve few examples. First one, the resistance of the filament in a light bulb is 1000 ohm. If the bulb is fed by the current from the source of potential difference 230 volt, how much current will flow through it? So resistance is given, that is 1000 ohm, and voltage is given 230 volts, right? So we have the formula I is equal to V upon R. So we will simply put the values, that is 230 divided by 1000. 0.23 ampere. So the current flowing through the filament of the bulb is 0.23 amperes. Example 2. The length of conducting wire is 50 centimeter and its radius is 0.5 mm. If its resistance is 30 ohm, what is the resistivity of its material? So the length is given 50 centimeter. Let us convert it into meters. So it will be 550 into 10 raised to minus 2 meter. Radius is also given in mm. So let us convert into meter again. And finally, R, that is given 30 ohm. So we have the resistivity formula. Rho is equal to R into A upon L. So R and L we have directly. We need to calculate A, that is the area. So the formula for area of the conducting wire, it is cylindrical, so pi r square, right? So we will put the values in this equation and we will have the answer as 4.71 into 10 raised to minus 5 ohm meter. So resistivity of the wire comes out to be 4.7 into 10 raised to minus 5 ohm meter. Next example, determine the resistance of a copper wire having a length of 1 kilometer and diameter of 0.5 mm. Resistivity of the copper is 1.7 into 10 raised to minus 8 ohm meter. And we will convert all the remaining units into meters. So we get the length as 10 raised to 3 meter and diameter is equal to 0.5 into 10 raised to minus 3 meter. Now, if R is the radius of the wire, then area of the cross section will be A equal to pi r square. So we will put the values over here and we will get the area. Now finally we need to put the values in this equation, that is R is equal to rho into L by A. So the resistance is 85 ohms. This is all for today's session. Thank you so much.